asked if how many I knew who I was and what I've done, but he already did that, so I don't have so much to say about that. But this whole lecture will be about thinking beyond what said you can do. Someone said, no, you can do that, but how can you pass the limits, or thinking outside the cube? So, what I hope I will talk about is, first one, who am I? I guess many of you don't know who I am, is I think. And then the oozing technique, and long puzzles, and also the dual layer icosahedron, as everyone has on the name badges. So, well, that's me, a few years ago. I am Ola Jansson. I am 18 years old, for about another 5, how many? 9.5 hours. I live outside Uppsala in Sweden, and I graduated this spring in a graphics at a school called GUC, or translated it's Graphical Education Center, and I am working at the Division of Communication at the Swedish University of Agricultural Scientists. Anyone here knows that university? No. Okay. So the oozing technique is, here you can see what I have everyone out there, but how you can take the floppy cube concept actually, but make it larger, make it even more pieces. Because if you take all these puzzles, the physics say you can't do it because it's one layer too much on each side, if you know what I mean, I hope. So, well, here's the first one, inventing the word oozing, as we can see here. I do not know who that is in real life, but that's his username on the Twist Puzzles forum. And that was in August 2009. So I'm going to give an example of a 5x5x3. Have everyone seen it on my desk out there? I think. So here you have a block of 3x5 cubes. That's the outer layer. So now to make a mechanism that reaches all corners, all pieces, we first take the regular mechanism, just put a cylinder on that. You see, it won't reach the outer pieces. So that doesn't work. The alternative to that is to extend the pieces. That way you reach out there, but looks pretty ugly, so people usually peel that to make the shape better. But still, you don't have the cubic shape of it. So what I did was make a cylinder that goes, a cone that goes all the way out, but then goes to a smaller cylinder on the inside. But still, you have a connection with all pieces, and then trim off the edges. That's basically the principle of the oozing technique. So here is a drawing that I made back in 2008. As if you know anything about, at least a little bit about twisted puzzles, you can see that this picture is a cutout of a floppy cube, the 3x3x1 cube. But the thing is, I draw this one before I even knew the existence of that puzzle. So it's inventing something that's already invented, as you can say. And this is also the technique that's used for all my puzzles. Now here's the example, the 7x7, which everyone knows is pillowed. And Tony Fisher is not here, because I won't have fun with him, because that's his picture. Well, as you know, the original is pillowed. And then Tony made it extended, so we have the same thing, extended to make the circles reach the outer corners. Then I made a design with my oozing technique, which was I made the same mechanism at the VQ7, but I shrinked it down so that I can cut out everything, because you cannot cut down a VQ7 to reach that kind of mechanism, because the ball on the inside goes all the way out to the outer pillow pieces, so you will cut out the mechanism if you do that. So I shrank it down, and then I also removed these little parts here to make it look even better, make the cubies. as you can see. Now, to hide this mechanism, since sometimes it makes pretty ugly and some think it's pretty cute, but one way here is say 5x5x7. It's not the one that has been made before. How many here have seen the 5x5x7? Two. Some. Well, that has another mechanism. This is a build-out of the Ishin mechanism. But here I took the concept, but just stopped right at the edge. So that way I would keep the mechanism inside the puzzle, which means not showing it. But still, if I would use the cylinder all the way out, it wouldn't work. The second is, well, the 7x7 again, and cutting down the pieces. So you'll get these cubic, but these ones will still be the odd shape. And we have the 4x4x2. This is version 3.5, I think. But Shapeways is messy, so I can't upload it there, so you can't get it. But here I made the same thing, but I didn't round off these corners here. So if you make this black and put stickers on, you better notice that it's cut out. The mechanism is there. Now to the next topic of the day. I hope I don't rush too much. But as you probably know, I had a 2x2x8 and a 2x2x9 on my desk. Which, if you think about Tony Fisher's 2x2x7, which pretty wobbly, pretty loose, and so I have this hooks all the way up. That way the pieces will not rest on each other, so one will hold to the other, which hold to the other, which hold to the other, and all the way down. The same mechanism, as many probably know, is used by Oscar in his 1x2x13. But there's the same. I think I asked you before, but since I had this design long before you made that one, but you didn't know that design, right?
Well, it was inspired on your design.
Yes.
It was inspired on your 1x2x5, yes. Which is the same concept, but a bit shorter.
Yes, but I mean these hooks out there that holds pieces together.
I don't know. Probably for guys like us, it's straightforward.
Yeah. Anyways. Yeah, so that's basically it. Have a long leg all the way down. It doesn't need to be strong because it won't hold the piece up. That's for this little hook. It will hold the piece up, so you can make it even thinner and even longer without having it fall apart and being bad. And then we have the other puzzle, the dual icosahedron, which is a Icosaminx version of a Gigaminx. Well, this was actually made as a challenge by Mr. Hellings to make one, because here is if you make it from a regular Gigaminx, these center parts will be very, very thin, and it will just look ugly, and these will be giant. So what I did was, here you can see the inside of a Gigaminx and the icosahedron. I took the cuts that goes here and bend them up, so the piece won't go in, it won't be so thin, or what you should say. And to do that, you can't just bend it up and hope it will be good. So, as you can see in these split parts I made, instead of going flat out just like this, as you usually do, I bent it up and made a cone shape of it. So that's basically it. And yes, I was pretty fast. Does anyone have any questions? No questions?
How many cuboids did you make? If you look at the Olsing technique, the first one you made was a
5x5x3 was the first one. And at the same time I made the 4x4x2. And then after that the 7x7x5 came and 5x5x2 and all those. And now, as some may or may not know, that a lot of people has used these techniques and been on to make it like Oscar and your super 2x2x3 and all those crazy ones. That's using the same technique, I guess. So that was basically it. Nice ending.
That's the one that goes beyond peta?
That's the zeta. It's
When we will see it?
Well, there is actually one guy who has ordered masters for it, but then he got divorced and I don't know what happened. We don't know.
It wasn't the fault of divorce, I guess.
This is like a 13 by 13.
Maybe, yes.
Yeah.
5, 6, 13.
What you do your designing in what kind of software?
I use Rhinoceros 4.1, I think. It's a CAD program used for mechanic designs and so.
Yep.
I have some basic questions. How expensive is it to make a puzzle like this? One prototype?
I don't really know, I haven't built anyone in that size, but what can it be?
Can you afford those yourself?
No, have to get a better job if I want to do that.
$1.50 per cubic centimeter. Do the math.
But perhaps there are different ways. So you can do the full printing, and then what Oscar says applies. What you can also do, and that's the way you made, for example, the DL.
The other way I made is print masters and then make molds and cast the pieces. That's how most of my puzzles are made.
My second question is, do you know anybody that can solve those puzzles? I think they are quite
Which one
Could you, Oscar, solve a puzzle like he made?
I have a screwdriver.
Like all these ones?
Yeah.
You mean? I can solve the 4x5x2. I've tried the 5x5x3 several times, but I always end up with some edges and some centers that need to be switched, and I have no idea how. And the 7x7x5, I haven't even bothered scrambling it.
So this is about trying to reach the limits of what is possible.
Yes.
Where is Jan? Because Jan usually.
And you can go on as the first picture was.
So maybe Dieter Gebhardt will explain how we have to do it.
Yeah, this one, but I'm not going to make it anyways. Say 9x9 myself.
Is there an upper limit on this technique? I mean, would it work 9x9x11 or 9x11x11 or 15 by, well?
You can do as much as you want, but it will just look, the more layers you put, the uglier it will be, basically. That's why I like.
Because you need a lot of curvature,
Yes.
and also
because
if you have two curves.
more
and
layers,
small.
the deeper the curves.
Yeah.
Then you can do, scroll down again, as I did with these two down here. I made both pulsing and pillowing to compromise two techniques to make these kind of puzzles. It won't be too ugly.
Okay, any more questions? Then I would like to thank you, Ola. Now, we gave Christian something on folding puzzles, but you are so much on the frontiers of puzzles, there's nothing there. So since it's the first time that you are in the Netherlands, I assume, he brought you something about the Netherlands. Thank you very much.
Thank you.